ever wonder how animals stay warm in the winter? Some animals are better adapted than others to live in cold environments. For example, let's take a look at two different but related species. The kit fox lives in the deserts of southwest North America. They have short brown fur and large ears. An adult fox weighs around 5 pounds on average. The Arctic fox lives in the Arctic tundra of North America. They have long fur that changes from brown to white in the winter so that they can camouflage in the snow. They have short ears. An adult fox can weigh anywhere from 7 to 17 pounds on average. That's a lot heavier than the kit fox. When we compare these two foxes, we see that the Arctic fox has more fur to help keep them warm. Because their ears are shorter and the foxes weigh more, they won't lose heat as quickly as the long-eared, skinny kit fox. Why is that? This comes down to surface area and volume. Surface area is the area on the outside of a shape or animal. Volume is the inside of the shape. Small animals with long ears and limbs have a large surface area compared to their volume, so it's easy for them to lose heat. In fact, many desert animals rely on this to stay cool. The opposite is true for large, stumpy animals that survive well in the cold. Because of their large size, they have a greater volume to hold on to the heat, and their shorter limbs and ears make their surface area smaller so they don't lose heat as quickly. This is what we will be testing in our experiment today. For this experiment, you will need containers of two different sizes. I'm using a large and small glass jar. We will be filling these containers with hot water and measuring the temperature over time with a thermometer. Do you think the water will stay hotter in the large or small container? Let's find out. After placing our thermometer in the small jar, I will fill the jar with hot water. Caution: ask an adult for help when using hot water. Our experiments should be fun and safe. Now I will read my thermometer to see the starting temperature, and I can record that on my data sheet. Then I will wait 1 minute and record the temperature again. I will repeat this for 8 minutes. Now I can repeat those steps with the large jar. According to our table, it looks like the large jar was better at holding on to heat. We can graph our results for another look. While both the large and small jars lost some heat, the small jar lost more than the large. That means that because the large jar has a greater volume compared to its surface area, it's better at holding on to heat. Now you try. Share your experiment with us.